Predictable state container for JavaScript apps. Yes, it is Redux. Predictable, centralized, debuggable, and flexible. With all that said, Redux is still a great product. Hello everyone, I'm Monica from Edureka. Welcome you all to this React.js Redux tutorial. Before starting the video, let me take you through the agenda of today's session. We will begin with understanding the need of Redux. Then we will understand what is Redux. Moving on, we will see what are principles on which Redux is based. Afterwards, we will get to know the components of Redux, and then we will learn how to set up those components and how data flows among those components. We will wrap up the session by understanding how to use React with Redux with the help of a small demo. As we are going to learn Redux, we should be clear with the purpose of learning it, right? So before we start with what is Redux, we should know why to use Redux. React is one of the most popular JavaScript libraries which is used for front-end development. It has made the application development easier and faster as it follows the component-based approach where the data flows through the components. Basically, React follows unidirectional data flow, that is, data always flows from parent to child component, where child component can never pass data back up to the parent component. As you can see on the screen, the colored circles are representing the components, where the upper component is the parent, while lower ones are the child or subcomponents. The view cannot interrupt in the data flow, so data flows in unidirectional fashion. Here data flows from parent to child. React does not provide any way for direct component-to-component communication, although React has features to support this approach, but it is considered to be a poor practice as it is prone to errors. As you can see on the screen, a child component can never pass data back up to the parent component, and here is the catch. So the question comes is, how can two non-parent components pass data to each other? This is where Redux comes into the picture. As you can see in the picture, a store is a place where you can store all your application state together. Now the components can dispatch state changes to the store and not directly to the other components. Then the components that need the updates about the state changes can subscribe to the store. So we can sum up into the points as Redux offers a solution of storing all your application state in one place called a store. Components then dispatch state changes to the store, not directly to other components, and then the components that need to be aware of state changes can subscribe to the store. Redux helps you manage global state, that is actually the state that is needed across many parts of your application. Redux separates the application data and business logic into its own container in order to let React manage just the view. React gives only the view in MVC model, where MVC stands for model, view, and controller. So we can say React is just the view, and to control the data flow, we use Redux as a data flow architecture. As you can see on the screen, React is responsible for the view, that is the web application on the browser, and Redux controls the data flow. Now let's understand what is Redux. Redux is a pattern and library for managing and updating application state using events called actions. Redux separates the application data and business logic into its own container in order to let React manage just the view. It's an application data flow architecture. Redux was created by Dan Abramov and Andrew Clark around June 2015. It was inspired by Facebook's Flux and influenced by functional programming language Elm. It got popular very quickly because of its simplicity, small size as of 2 KBs, and great documentation. This is the basic idea behind Redux, that a single centralized place to contain the global state in your application and specific patterns to follow when updating that state to make the code predictable. So basically, the patterns and tools provided by Redux make it easier to understand when, where, why, and how the state in your application is being updated, and how your application logic will behave when those changes occur. Redux guides you towards writing code that is predictable and testable, which helps to give you confidence that your application will work as expected. Now, let's look at the principles of Redux. Redux follows 3 fundamental principles, where the first one is single store, or we can say single source of truth. The second principle is state is always read-only, and the third one is changes are made with pure functions or reducers. Now, let's understand these principles in detail, starting with the first principle, that is single store. So when I say single store, it means that all my application state are stored in a single immutable store As with only React unidirectional data flow, direct communication between components is not allowed. Now, the state of the entire application is stored in an object or state tree within a single store. Components state is stored in the store and they receive updates from the store itself. So components dispatch something to the store, and then the other components, when they get to know that something has been updated, they subscribe to store. Now, let's move to the second principle, that is the state is read-only, which means the only way to mutate the state is to emit an action which describes the user's intent. Here by mutate, I mean is to update. So we can say that we can change the state by triggering an action, which is an object describing what has happened. As you can see on the screen, here the action is no action. And when the action is switched on, the bulb is getting lighter. Now, let's talk about the third principle, that is change using only pure functions. In Redux, pure functions are called as reducers. The reducers are used to indicate how the state has been transformed by action. The reducers or pure functions take two parameters as input, which are the previous state and the action. So when it takes the previous state, it gives us the new state. As you can see in the picture, the previous state is that the bulb was not on, and then it has been worked upon by the reducers, and then we get the new state, that is the bulb is on. Now I'm going to talk about the components of Redux. Redux has four components: action, reducer, store, and view. So let's understand these components in detail. Starting with the action. Action are the plain JavaScript objects which are payloads of information for the store. So basically the only way to change the state content is by emitting an action, as we have already talked about it. So here action means plain JavaScript object which are the main source of the information which we use to send data, and data could be user interaction, internal event like API call or form submission. We can send these from the application to the store, and then the store receives this information only from the actions, and then we have to send the actions to the store by using store.dispatch. For example, here as you can see, we define the type as add to do, and then we can define the parameters as text. Now actions are created by action creators. Some of the points to be considered in actions are that it must have type property that indicates the type of action being performed. They must be defined as a string constant, and you can add more properties to it. Now talking about the action creator, action creators are the functions which create actions, and they takes in the message, converts it into system understandable format, and returns a formatted action object. Action creators are the normal functions that return the function, and to call this action anywhere in the application, we can simply use the dispatch function, where we can define dispatch, and then we can define it to do add to do text as a part of dispatch method. So here we can add dispatch. After action, we have reducers. Basically, actions describe the fact that something happened, but they don't specify how the application state changes in response. So here comes the job of reducers. Reducers are pure functions which specify how the application's state changes in response to an action. It is based on the array reduced method, where it accepts a callback, a reducer, and let us get a single value out of multiple values. So we can define reducers as pure functions which specify how the application state changes in response to an action. Some pointers to be considered for reducers are: they do not change the value of the input parameter. They determine what sort of update needs to be done based on type of the action and returns new values. It returns the previous state if no work needs to be done. The root reducer slices up the state based on the state object keys and passes them to their respective specialized reducers. Reducers don't manipulate the original state passed to them, but make their own copies and then updates them. Now let's understand the reducers with the help of a simple example. Here we have defined whole function reducer with the arguments initial state and action. Then we can use simple switch action type. In the case add to do, we are returning the object assigned to state, and then here we have a to-do list. Then in text, we are going to work on the action.text. And then completed should be false. That is what we are going to return the state itself. So here we are taking help of previous state, action, and new state as part of reducer component. We should avoid the following things inside a reducer: that mutating its arguments, that we should not change the arguments inside a reducer. We should not perform side effects like API calls and routing transitions, and we should not call non-pure functions like date.now or math.random. Now, moving on to the star component of Redux, that is store. Store can be defined as an object which brings all the components to work together. It calculates the state changes and then notifies the root reducer about it. So basically, store can hold the application state and provide some helper methods to access the state, dispatch actions, and register listeners. So the entire state object tree of an application is saved in a single store. Here, we can pass the middleware to the store to handle processing of data and to keep a log of various actions which can change the state of the source, and all the actions return a new state by the reducers. Here in the example taken, we have created a store from Redux where we can import to-do app from the users that we are going to create, and then we are going to use the store component as a part of stores. With store, the data state can be synchronized from the server level to the client layer without much difficulty. This makes the development of large applications easier and faster. Store is responsible for holding application's state, allowing access to state via getState method, registering listeners via subscribe listener, allowing the states to be updated via dispatch action, and also it handles unregistering of listeners via the function returned by subscribe listener. Now let's talk about the last component, view. View is nothing but the thing which is displayed on the screen, and in formal terms we can say view displays the data provided by the store. As you can see in the picture, the store provides the data which is displayed as view on the browser screen. Smart and dumb components together build up the view. Smart components are the managers who are in charge of the actions and pass down a function via the props to the dumb components. And dumb components provide information to the smart components if any action is required. They receive them as props and use them as callback. Now, let's understand how the components in Redux are set up. First of all, we have to get the store ready. Then we have to set up the communication amongst the components, and then we have to prepare the action callbacks. Let's understand it with an example. So here we have action creator, reducers, views, store, provider, and root reducer component. So these can be called as the various roles involved in setting up the components and then ultimately in the data flow. Now let's see how the communication will happen among these components. So first step is to get the store ready. Here in the example, the store has been hired and the reducer team has been asked to help the store out. So here in the example, the store has been hired and the reducer team has been asked to help the store out. Then in the next step, that is setting up the communication between the store and other components, we can see the example where the root component says to the provider that this store is hired, and now the provider has to set up the network to keep the components updated, and here's the view part. So view will get connected to the latest updates to display the user. Now the final step is to prepare the action callbacks. So here the view part has to make it easy for dumb components to understand. It has to bind the action creator and the dispatcher so that the dumb component can just call the callback. As we know, if something has to be updated as store is immutable, an action has to be triggered, which can be done by action.dispatch method. Now let's understand the data flow. That is how data will flow among all these components of Redux. So Redux architecture is concentrated on a strict unidirectional data flow. In an application, all the data follows the same lifecycle pattern, making the logic of your app more predictable and easier to understand. It also encourages data normalization to ensure consistency. The picture represents the flow diagram of the Redux application, which contains all the components which we have discussed. Now let's understand the data flow with the help of this example step by step. Starting from here where the name is John, we want to update it with something else, so it will start from action creator. Starting with the step 1, so the action type is name update, value is John. This is available on the view, and to change it, an action has to be triggered. Now the second step where the store will get informed by the action. Store has the current state tree, and now it will be passed to the reducer to calculate how the new state tree should look like. So in the third step, the reducers, which are the pure functions, will get the previous state or previous state tree and action as input and will provide the new state. Now in the fourth step, the root reducer will provide the sliced state tree to other reducers. In the fifth step, the other reducers will copy the sliced data and will update it, and it will show the root reducer that how the sliced state tree will look like. And in sixth step, the store will be updated, and then store will inform the provider with the new state tree or the new state, which will complete the step 7 and step 8. And finally, in the step 9, the new state tree will be updated, which we can re-render as the component tree. So I would sum up the entire process in the following brief steps. Starting with initial step, a Redux store is created using a root reducer function. The store calls the root reducer once and saves the return value as its initial state. When the UI is first rendered, UI components access the current state of the Redux store and use that data to decide what to render. They also subscribe to any future store updates so they can know if the state has changed. Talking about the updates, something happens in the app, such as a user clicking a button. The app code dispatches an action to the Redux store like dispatch, and the type could be counter or increment. The store runs the reducer function again with the previous state and the current action and saves the return value as the new state. The store notifies all parts of the UI that are subscribed that the store has been updated. Each UI component that needs data from the store checks to see if the parts of the state they need have changed. Each component that sees its data has changed forces a re-render with the new data so it can update what's shown on the screen. Now we will see how to use React with Redux. So to install the stable version using npm, we can use the command npm install redux, and to yarn, we can use the command yarn add redux. React bindings are not included in Redux by default, so you need to install them explicitly using the command npm install --save react -redux. You have to add these dependencies along with Babel, React, and Webpack. Now, I will show you a small demo of using React with Redux. So let's start with a demo. In this, let's first see the structure of the whole project. So we have created these folders, actions, components, containers, reducers, and the main file index.js. So these all are the components which we have seen while understanding this React.js and Redux. So starting with this main file, so index.js is always the first or the main file of a React Redux application of project. So in this, we are using a special React Redux component called provider, as you can see here. So this one is the special component, and it makes the store available to all the container components in the application without passing it explicitly. So we need to use it once when to render the root component. So here you can see we are rendering the root component with the name app. So here we are using provider. So we have to use it once while rendering the root component. Now we have created this file by importing all the dependencies required. You can see here with the help of import statement, we are importing all the dependencies which are required. It could be like Redux, React Redux, or the components or the reducers and all these things. Now, as you can see here, all the dependencies, React, React DOM, and here this React DOM, that is actually the data object model, which you would have learned in JavaScript. So in this file, we are calling the utility called as provider to call root component. And now let's start with the components. So here you can see the folder components. So these all are the different components which we have created. So these components could be presentational components as well as container components. So most of the time we use presentational components, but sometimes we generate container components as well to connect to the Redux store. So first of all, we'll see the presentational components. So here we have to-do list.js, to-do.js, link.js, footer.js, and app.js. And here, this app.js is the root component. Okay. So starting with the to-do list.js. So this to-do list.js component or the file contains the to-do list, which is showing the visible to-dos. Okay. And basically these to-dos are the arrays. As you can see here, these to-dos are nothing but the arrays which have been created using three properties. You can see here ID, completed, and text. And here on click, you can see here on click is an event or a function which is taking ID. Okay, here is taking ID as a number, which is a callback to invoke when a to-do is clicked. Now talking about the other file, that is to-do.js. Here it shows a single to-do item. Here is a property. You can see here property types. Okay. So it has a property type which has the event on click and completed and text, which shows the completed to-dos. Now we have one more component, that is link.js. So it has a link and it will show all the completed to-dos. Now then we have the footer.js. Here you can see they have different links which are used for the filter. As you can see, with the help of filter link, it allows the user to change the currently visible to-dos. When we will see the output of this application, then we will see how we can change the to-do list items with the help of this filter link. Now talking about our root component, that is app.js. It is calling all the other JS files which we have created as presentational components. You can see here like this add to do, visible to-do list, and footer. So you can see this footer is also one of the presentational component over here. So it is calling this as well. And you can see these visible to-do list and add to do, all these are the container components. So this root component will call both the components, presentational as well as container. So as you can see here, import as well as the export method. Okay. So initially we have imported presentational component like footer and the container components like add to do and visible to do list. Now you can see here, when you will just hover your mouse over here, you can see from where these components are coming. So you can see from the src folder and the container folder, we are getting this visible to do list. It is a container component. And here for footer, you can see it is coming from the components folder, this footer.js. So this is a presentational component. Now here we know we require the container components to connect presentational components to Redux. So let's see the container components. Now here inside the container folder, we can see the container components present. So these are the visible to-do list.js, filterlink.js, and add to-do.js. So starting with the visible to-do list.js, which we have created here, you can see this file is required by to-do.js file, which is a presentational component. So here we have to-do.js, which is a presentational component. It will require this container component, that is visible to-do list.js. This is the basic idea, and it helps to subscribe to the Redux store, wherein we have map state to props. Here you can see this map state to props, which is a special function available in this import connect from React Redux. Here you can see in this connect function, this map state to props is present. So it is a special function which will help to subscribe to the Redux store. Now, one thing to pay attention is to import connect function. Here, as you can see, while importing, we have imported a connect function as well from React and Redux library. What it does is it provides the optimization which avoids unnecessary re-rendering of the application. Here, we are calling the function with the help of getVisibleToDos utility. So we have a switch case in which we have three cases. All these three cases are actually the actions, which are show all, then show completed, and then we have show active. These are actually the to-dos. The action is to show all to-do items, then show all completed to-do items, and then show all the active to-do items. Now talking about this filterlink.js, here it is a container component which is rendering the links by dispatching an action. As you can see over here, with the help of this map dispatch to props utility, which we have got from this connect function, which we have imported from React Redux library, it is rendering the links by dispatching the action. And now talking about this add to do.js, here this is returning the HTML part of the application. As you can see here, we have input value, we have the button, submit button. So when we will see the output there, you can see the HTML part which will be visible on the screen. So that part comes from this add to do.js file, which is actually one of the container components. Now talking about the actions. Now you can see here the actions. Here action is also one of the major component of our Redux application. So here in this actions, index.js, the actions are add to do, then set visibility filter, and toggle to do. Now let's talk about the reducers. After actions, we'll move to the reducers, and in the reducers, we have different reducers present over here: index.js, todos.js, todos.spec.js, and visibility filter. Now in this index.js, we are making use of combine reducers utility, and we are combining all the other reducers present. As we have seen in the example earlier, that we have a reducers team where multiple reducers are the part of that team and they together work. So here, with the help of this combine reducers utility, which we have imported from this Redux library with the help of import statement, we are combining the other reducer functions. Now, as we know, these reducers are basically the pure functions. So other reducers, as you can see over here, these reducers are nothing but the pure functions, which are returning something based on the action. So here you can see they are taking the action with the help of the ID, and then they are returning something with the help of the case. So they are returning the states, as we have understood earlier from the examples. And we will make use of all these reducers here by combining them. Now, let's talk about the output of this application. I hope this structure of our Redux application is clear to you all. You can create any of the applications on Redux. And now, talking about the output. So here in the output, you can see we have a text box and then the submit button and the other buttons also. We will see how they will be used. Now, the basic idea of this application is to create a to-do list. Okay, so here we will add some items which will be treated as the items of to-do list. So we can add multiple items in this to-do list, and then we can categorize them with the help of clicking on those items, that whether they are active or they are completed. Right now, we don't have any item in this list. So let's insert something. So for example, we are entering to subscribe the Edureka channel. So when we will click on add to do, this item has been added in the to-do list. For example, we can insert like the video, one more, and for example, we'll write like writing. So all these three items I have entered in this to-do list. When we have clicked on all, so we can see all the items of to-do list. When we will click on the active, so we have all the active to-do list items, and in completed we have nothing because we have not completed any of these. To complete it, we will just click on any of these. So to subscribe, I have just clicked on it. So this item has been completed. Now when we will see in active items, we have only two, and in completed, we have the one which we have already completed by clicking on it. So this was the output for this application which we have created. With this, we have come to the end of this session, and hope it was useful for you and you have enjoyed it. Thank you.